Does the molecule He2 exist? We can answer this question by drawing the molecular orbital diagram for He2. Start by drawing in the highest energy atomic orbitals associated with an individual helium atom. By looking at the periodic table, we can see that the electron configuration for helium is 1s2, telling us that the highest energy atomic orbitals for helium are the 1s atomic orbitals. So, to start a molecular orbital diagram, we can draw in the 1s atomic orbitals for helium at the same energy level. Then, we need to draw in our molecular orbitals for the helium molecule. For He2, there will be 2 molecular orbitals, because we start off with 2 atomic orbitals. One of these molecular orbitals will be higher in energy than the atomic orbitals, and one will be lower in energy. Remember to connect your new molecular orbitals with the original atomic orbitals for your individual helium atoms. The molecular orbital that is lower in energy than the atomic orbitals is a bonding molecular orbital, called the sigma 1s bonding molecular orbital, and the one that is higher in energy is called an antibonding molecular orbital, and it is called the sigma 1s star antibonding molecular orbital. Now, we need to fill in the atomic orbitals and molecular orbitals with electrons. Using rules such as Hund's rule, the Aufbau principle, and the Pauli exclusion principle, we can fill in these orbitals. First, we need to determine how many electrons each individual helium atom has. The answer to this is 2 electrons. And these 2 electrons will add together for He2 to make a total of 4 electrons for our molecular orbitals in the middle. First, we will fill in the 2 electrons for each individual helium. Just like that. And then these 2 electrons will fall into the molecular orbital. According to the Aufbau principle, we start by filling up the lowest energy level first. And each molecular orbital can hold 2 electrons. And then the remaining 2 come to fill the antibonding. And that is our completed molecular orbital diagram for He2. Now, what does this tell us about if the molecule exists or not? Well, to determine if it exists, we can find the bond order. And the bond order is a measure of the number of electron pairs that are present in a bond between the helium atoms in the He2 molecule. The formula for bond order is 1/2 of the total number of bonding electrons that are present in the sigma 1s bonding molecular orbital minus the antibonding electrons, which are present in this higher energy sigma 1s star antibonding molecular orbital. If we calculate this out, we find that the bond order equals 1/2 times the bonding electrons, of which there's 2 right here, minus the antibonding electrons, of which there's also 2 up here. 1/2 times 0 is equal to 0, or in other words, there are 0 electron pairs that exist in a bond between the helium atoms in an He2 molecule, which tells us that there is no bond between He2 and that the He2 molecule does not exist. That's it for this video. Thanks for watching.